Okay, this is Math 6, Module 6, Lesson 8, Variability in a Data Distribution. So whenever you hear the word variability, you need to think about how does it vary or how is it different. Okay. So in example 1, it says comparing two data distributions. Robert's family is planning to move to either New York City or San Francisco. Robert has a cousin in San Francisco and asked her how she likes living in a climate as warm as San Francisco. She replied that it doesn't get very warm in San Francisco. He was surprised by her answer because temperatures was one of the criteria he was going to use to form his opinion about where to move. He decided to investigate the temperature distribution of New York City and San Francisco. The table below gives average temperatures in Fahrenheit for each month of the two cities. So this is Fahrenheit now. All right, and then there it is. So, what do you notice about the temperatures of New York City? Well, the average monthly temperatures vary quite a bit through the year. We have a 39 here. We got an 85 here. That's quite a bit of difference. So, what do you notice about San Francisco? Well, think about what we're just looking at. And the lowest temperature is a 57, but the highest temperature is only 68. Oh, well, nope, there's a 70. Okay, so there's not that much of a difference. Only about 13 degrees. So they don't change a lot month to month. So looking at the same data, it says calculate the mean of the monthly average temperatures for each city. Now the mean, how do we do that? We're going to add up the sum of the data. You're going to have to get the sum of the data for each one of those. And then you're going to take how many values there are. So the total number. Okay. So we know that there's going to be 12, right? Because there's 12 months in a year. And so we just have to add up all of New York City. So we would say, let's say New York. And then we'd have San Francisco. All of them added up to be, so let's call them the sum of New York and the sum of San Francisco divided by 12, or the total number. So when we do that, we would get 63. Okay, that is the average temperature, which is, that would be New York, the sum of New York. I'm trying to write this all a little bit better. The sum of New York is equal to 756 divided by 12, which means the mean is 63. Okay. Now, it was 64 for San Francisco. So there's not that much of a difference then. That was 768 for the sum of San Francisco divided by 12 gives you 64. Not a lot of difference in the average monthly temperatures. Recall that Robert is trying to decide where he wants to move. What is your advice to him based on comparing the means of the monthly temperatures of the two cities? Well, the means, once again, 64 and 63. Not a lot of difference there, is there? So, since they're almost the same, it looks like Robert can move to either city. Even though the question asks students to focus on the means, they might make a recommendation that takes variability into account. How much do they vary, right? Remember, New York varied a great deal from 39 up to 85, where San Francisco was 57 to only 60, well, 70 here. Okay, so you may base it off of that. Do you want the temperature to be about the same every month, or do you want it to get cold and then you want it to get hotter in the summer? Okay, page 3. Now we're understanding variability now. It says maybe Robert should look at how spread out New York City's monthly temperatures data are from the mean of New York City, okay, and how the spread of San Francisco is. So to compare the variability of monthly temperatures of the two cities, it may be helpful to look at a dot plot. The dot plots of the monthly temperatures distributed for New York City and San Francisco. So here's your dot plot, okay, for each city. Now, if we look at these, what can you tell? These, actually, I think there's another one over here. Yeah, so there's another one there on the other side of 40. So from here to here, and from here to here. So this varies a whole lot more, whereas this only varies this much. So mark the location of the mean of each distribution. Well, this one was 63, and this one was 64. Okay. So basically, let me try and get those a little bit more accurate. 64, 63. Now, so the symbol it wants us to do is a balance beam kind of, or not a balance beam, but a pyramid where it would balance. How do the two distributions compare based on their means? Okay, so based on their means, they're about the same, right? Both about the same. But if we describe the variability of the monthly temperatures, look at as opposed to the mean, well, it's a lot more spread out for San Francisco. All right, I'm sorry, for New York. This is New York. This down here is San Francisco. So New York's much more spread out. We got to go all the way over here to get to the high and all the way down here to get to the lowest. But here, for San Francisco, we don't go that far. So the temperatures are spread out about the mean for New York, and they range from 39 to 85. But for San Francisco, the temperatures are clustered. So they're just right here all grouped together. Not that big of a variety. Only from 57 to 70. So, comparing the variability of the two distributions, is the variability about the same or different? Well, it's going to be much different. New York City is a greater variability. It's spread out a long ways over here, all these values, whereas we just got a small variability here. So it differs. There's not a bunch of difference in the values. Okay. If Robert prefers to choose the city where the temperatures vary the least from month to month, where would he choose? Well, these vary the least in San Francisco. You're only going to be from somewhere between 57 degrees to 70 degrees. So think about it like this. You're not having to buy a real big jacket or anything like that because it's only going to be, the low is only 57 degrees. Okay, where in New York, it could get down to 39 degrees, which is much colder. And it gets much hotter too. So you got to wear shorts and a heavy jacket in New York. Where in San Francisco, you may just wear long sleeves and long pants. So on page 5, it says, consider the mean and the variability in a data distribution. The mean is used to describe a typical value. Typical. What is typical? What is normal, in other words? We try and use normal. Typical, normal value. okay, for the entire data distribution. Sabina asked Robert which city he thinks has the better climate. What do you think would be Robert's response? Well, he responds that they both have about the same mean, but the mean is a better measure or a more precise measure than the typical monthly temperature for San Francisco than for New York. Now, why would he say that? Why is the mean a better measure for San Francisco rather than New York? Well, that's because New York varies more. The temperatures vary more. So it's not as an accurate statement. I mean, it's an accurate statement, but it's not as telling. Okay? It's not as, it could be a lot different. If you said it's 63, the average is 63, well, if it's one of those 39-degree days, that's really different than 63. But in San Francisco, if it's only 57 degrees, that's the lowest there. Well, that's much closer to 63, right? So Sabina's confused and asks him to explain what he means by this statement. How could Robert explain what he means? Well, the temperature in New York City in the winter are in the 40s, and in the summer they're in the 80s. The mean of 63 isn't very close to either of those temperatures. Therefore, the mean is not a good indicator of the typical month's temperature. The mean is much better an indicator of a typical monthly temperature in San Francisco because the variability of the temperature there is so much smaller. Consider the following two distributions of time it takes 6 students to get to school in the morning and to go home from school in the afternoon. Okay? 6 students, morning times, afternoon times to get to school, go to home. To visualize the mean and variability, draw a dot plot of each of the two distributions. Okay? Looky there. There it is. Here's the morning. Here's the afternoon. Both measured in time or in minutes. And there's each point. Now, what is the mean time to get home to school in the morning for these 6 students? Well, we know we're going to divide by 6, right? Because we've only got 6 values for both of these because there's 6 students. So then we have to take the sum. We'd add up all of these to see what we're going to divide by. Okay? So if we do that, the mean is 14 minutes for home to school. So that would be in the morning, right? So this is 84. So 84 divided by 6 is 14. Now, to go home in the afternoon, it is also 14 minutes. So if we add up all of these, we would get 84 again. So this is 84 divided by 6 again. Now, for which distribution does the mean give a more accurate? Remember, it's more accurate when it's least varied. So let's look up here again. When is it least varied? Well, right here in the morning time, right? Or here to here, as opposed to this wide vary. So the mean is a better indicator when it's least varied, which would be here and here. The morning is a more accurate indicator. The spread in the afternoon is too wide, too greater. All right, number 12. All right, we're looking at jelly beans, green jelly beans. Okay. Different manufacturers. The mean in each distribution is 42 green jelly beans. Okay. So we got 7 bags. Each distributor or manufacturer And this is how many green jelly beans are in each one. Okay, so it says draw a dot plot of the green jelly beans and mark the location of the mean with a with our triangle there. Okay, so let's do it if it will let me. Okay, here we go. Now, the dot plot should have a balancing symbol located at 42. So let's do this. Here we go. These are all of them. Okay, so if we do 42 right here, 42 right here, 42 right here, and let's see here. We got 42 over here and 42 right here. Now, I was going to ask you a few questions here. Which one is a better indicator? The 42, which one would it be a better indicator for? Remember, we're looking at the least varied, and here it is. There's not a lot of variation there. We're going from 40 to 46. Very little variation. So which one has the greatest variation? Which means which one is spread out more? Well, the best brand here. It covers this whole spread. That's a greater variation. They're all different. Notice how these are not all different. They don't vary that much. We've got 2 that are 40, 2 that are 42. There's not a lot of variance there. Okay. Now, we can compare distributions based on their means, but variability must also be considered. The mean of a distribution with small variability, which means there's not a lot of spread, is considered to be a better indication of a typical value than the mean of a distribution with a greater variability. So the mean is a good indicator when it's a small spread or a small variability. It's not a real good indicator whenever it's a great spread. Okay.